Welcome back to the SWAYAM NPTEL course on mechanical and electrical systems of mining machines. Today we will be going through lecture number 25, that is on dragline, and it is a part of module 2, that is mechanical systems in heavy earth moving machineries. The content of this lecture would be as such. We will first go through the introduction of the dragline, and then we will be going to the classification of dragline. We will be then understanding the components of dragline. In components, we will be understanding the bucket, boom, power transmission system and undercarriage unit in details. Well, now when we talk about dragline is one kind of pure type of excavator, and it is a intermittent discharge type of excavator. What does this mean? That it does not cut continuously, it does the cutting intermittently, rather it does the filling of the bucket intermittently and then dump it directly onto the dumping site. Well, when we talk about dragline, it is mainly used for removal of overburden. It is not used for directly penetrating onto the virgin rock. First, the overburden is loosened by drilling and blasting method. With that, the virgin rock gets loosened, that is the overburden gets loosened, and thereafter this dragline is used to take away or drag the material into its bucket and then dump it directly onto the dumping site. Now, if you can see from the picture here, this is how a dragline looks like, and you can see it has a very long boom. So, the range or the length of this boom ranges from 9 to 96 meters. So, when you lay a 96 meter horizontally, you can be able to cross a small river. So, that is why this machine is very much useful in case where the overburden can be removed directly by dragging onto the overburden, the loosened overburden, and then this machine swings to directly dump the material to the dumping site. So, this reduces the use of auxiliary machines like dump truck or payloaders, which actively helps in removal of the overburden and transport it to another dumping site. Now, as the name tells, the drag line. So, what does it do? This bucket would drag the material into it by using these ropes. You can see there are multiple ropes which I will be discussing it in details, and it fills the material and dump it. So, that is how the name of this machine came as dragline. However, if you can see, unlike other machineries, the bucket has to be controlled by two ropes only. One we call it as a drag rope and one is the hoist rope. So, that is why the skill of the operator is very much necessary. A highly skilled operator is required to control the drag line. Now, since this removes the use of any auxiliary machine or any active transport machinery, so this is one of the cheapest means of overburden removal. Well, when we talk about such machines, so we see that there is a range of boom length that the different manufacturer manufactures, that goes from 9 to 96 meters, and with this the capacity of the bucket is also planned accordingly, and depending on the size of the mines, the appropriate dragline of specific boom length and bucket capacity can be selected. Now, another advantage of dragline is it can work below the working level. It can dig below the surface level of the of where the dragline is standing. Now, coming to the constructional features of this dragline. So, As we can see, this is the boom of this complete, the long length that we see here, it is called as the boom of the dragline. Now, this is the superstructure onto which the complete control panels and the controlling motors are housed onto, where there are multiple sieves are housed which are connected to different motors for operation of the complete drag line. So, this is the foot of the drag line. So, the drag line again can be of two types, one is a crawler mounted and one is a walking kind of drag line where it is tub mounted. So, what is a walking kind of drag line? I will be explaining while I go through this lecture. Now, the most important thing of this drag line is the bucket that you see here. Now, this bucket is connected to two ropes. One is the hoist rope here and the other is the drag rope here. We also call it as drag cable. So, this is the hoist rope or hoist cable. Now, these are connected to two sleeves. So, here it is connected to one sleeve and here there is another sleeve. So, onto the sleeves there are two chains, one is a hoist chain which is connected to the hoist rope side and another is a drag chain which is connected to the bucket on its front end. So, you can see from this end only the drag line bucket gets filled up. So, this side is the open side and to this drag chain is attached onto the two ends of this bucket, like the two sides of this bucket, and here the hoist chain is connected to the spreader bar and it is connected to the other end which is the closed end. So, this bucket is closed from four sides, that is the two side, bottom and the front side, and it is open from two sides, that is from this rear end and the top. So, to this rear end the drag chain is attached and to the closed end that we call it as the front end is the hoist chain is attached. Now, in between these two sleeves there is another cable which we call it as the dump cable. So, these three cables or ropes, they help in filling up of the bucket and then dumping of the material appropriately when it carries the bucket to the designated site. Now, along with the hoist rope or drag cable, you can see the hoist rope goes along here and it is connected to one drum. So, this is the bucket hoist cable or rope that we say. There is also a boom hoist cable. So, this boom can also be moved up and down depending on the requirement. Now, if the drag line has to dig below the working level, that is, let us say this is the working level and here there is a pit and it has to work below the working level. So, the boom height can be adjusted. Now, this boom height is connected to the A frame here which gives the stability of this boom. Now, this boom hoist cable is again controlled by a sheave and a sheave the boom hoist cable motor which helps in the moving up and down of the boom. So, this is how realistically it looks like. Now, coming to the classification of a drag line. So, it can be either self propelled or it can be propelled by external agent. Well, when we tell about a self propelled drag line, it can be crawler mounted or it can be a walking drag line. Now, we will discuss in details about the crawler mounted and walking drag line. Well, when we talk about the drag line which is propelled by external agent, it can be wagon mounted or it can also be track mounted. Okay. So, in track mounted there may be a steam engine. Nowadays we do not find a steam engine, but there may be an engine which would be propelling the dragline, or it can also be a wagon mounted which should be pulling the dragline. Now, about crawler mounted excavators, we have discussed it in details, and almost 3 machines we have already discussed about discussing the constructional features of a crawler. However, we have never discussed the constructional features of a walking dragline, of how it can walk. It can walk just like a human being with its 2 feet. This dragline can also walk. So, well, when we talk about this crawler mounted dragline, so it has 2 crawler units as those of a shovel or bucket wheel excavator that we have already discussed. However, when we talk about its travel mechanism, swing mechanism, boom hoist mechanism and bucket hoist mechanism, it is also same as that of a shovel. So, in addition to these, there is a bucket dragging mechanism which is introduced to drag the buckets towards the machine during the excavation. That is how the bucket gets filled with the material, and then the whole superstructure of the drag line, it swings to dump the material at the dumping site, and it can reach to the dumping site just because it has a long boom. Now, when we talk about the components of a drag line, so what all it has, we have already discussed, that is the bucket, this is the bucket, this is the boom, power transmission for bucket operation, boom hoist and swinging motion. So, I will be showing you a electrically operated drag line which should be having different motors which helps in the different operations that is required for the functioning of a drag line. Now, it also has a walking mechanism which is very much special to a drag line. So, we can see this kind of walking mechanism only in a drag line, not in any other kind of machine. Then it has a undercarriage unit. As you can see, this is the undercarriage unit as we have been discussing for other machines. So, it has a deck onto which there are multiple motors and sheaves and the A mast, the boom is also attached there, and all the operators cabin and everything is on this in this undercarriage unit, or this what this we call it as a working deck. There it also has a lubrication system as we have discussed in our last lecture, like in bucket wheel excavator. Now, when we talk about buckets, they are again available in 3 models, that is light, medium and heavy duty bucket. However, if we see specifically how does a bucket looks like, it looks something like this, which is a rectangular section box type component with opening on one side. This is the opening side, and top also it is open. Then it has a spreader bar. You can see there is a spreader bar here which is attached to this chain, which we call it as the hoist chain. What do we call this as? This we call it as the hoist chain. Now, this is the socket or the sleeve onto which this hoist chain is located onto, and from here goes our hoist rope. So, to the other end where the bucket teeths are there, onto that the drag chain is attached to both the sides, as you can see here. So, this is the drag chain that we can see, this is the drag chain, and at the end there is a drag yoke, and to this drag yoke at this end goes the drag rope. Okay. So, in between that this drag yoke and dump hoist sleeves, you can see how a dump cable is attached. So, there is a pulley kind of thing which is attached to this U shaped structure, which helps in dumping of this dumping of the material from this bucket. Now, this hoist cable moves over this dump sleeve housing and is attached to the drag yoke, where the drag chain and drag ropes are attached. Now, in between this hoist chain, as discussed, we have a spreader bar. So, above this, when the dragline bucket gets filled, so above this point or level, the material will not get filled, and this spreader bar helps in spreading the material uniformly onto the inside volume of this bucket. So, there are also perforated wall designs are available, and this digging teeth of the buckets that we see here, it is not permanently welded, but they are replaceable type. They are, some of them can be welded, but they can again be detached, so that they can be replaced with a new ones. Now, this slide shows the functioning of how the bucket gets filled. So, this is what you are seeing, the swinging action, and now this is working below the like this dragline is operating below the working depth. As you can see here, the hoist cable is now in operation, which has loosened. Now, the drag rope is in operation, which is pulling the bucket towards itself, which fills up the bucket to certain level. Now, with the help of joystick, you can see the operator is balancing the hoist rope and drag rope, and now the drag line is again swinging to the designated place where it would be dumping the material. While dumping the material, the hoist rope would be pulled up, so that the bucket will be pulled up. So, when the hoist rope gets pulled up, the dump cable gets activated and dump the material onto the dumping site. So, as I have explained in my last slide, so this is the hoist rope, this is the dump rope or the dump cable. So, this is the coupler or the drag yoke, So, from here goes the drag rope, and then there is the clamp here, which clamps the drag chain onto the two sides of this bucket. So, this we call it as the lip of the bucket, which helps in penetrating into the loosened overburden rock and fill the bucket. This is the bucket body, and this is the lug that helps in connecting the hoist chain to both sides of the bucket. Now, coming to boom, the boom can be of three types. It can be a short length boom, it can be tubular column type boom, or it can be a long length truss boom. So, what is the difference between these three is first their length. When we talk about a short length boom, so you can see here this boom does not have a very large length, or it is not that long, and it looks in form of a eye. So, at the middle it has the width is more, and at the end the width is very less or almost pointed. So, this kind of booms, they are used in smaller size drag line, where the length is around 9 to 15 or 20 meters. So, the shape of this boom resembles that of a truss member that we are seeing, but they are not made up of solid bars. However, in tubular column type, so here the boom length is very long. So, it can go from around 80 meters to 96 meters, Now, in such tubular column type booms, due to its length, so the stability of this boom has to be maintained while the bucket is in operation. So, that is why there are multiple stay ropes. So, you can see these ropes that are attached here. So, they are here also, let us say it is connected something like this. So, these multiple stay ropes are used for the stability of the boom while it is in operation. Now, all these stay ropes are connected to the A mast. So, one thing that I missed telling is about the fair lead. Now, you see when this drag rope is operating, how it would follow a guideways. It would pass through the fair lead. So, the fair lead are some slot kind of thing which are just below the boom, which helps in the which gives guideways to the drag rope or drag cable. Now, this tubular column type of booms, they they may be made up of solid cylinders or they may be of hollow cylinders, and with these stay ropes they can achieve the stability. So, this type of boom is generally used in 15 by 90 dragline. So, what is 15? 15 is the cubic meter of the bucket, that is the volume of the bucket, and 90 is the length of the dragline. Now, when we talk about long length truss boom, it also has a tubular framework where the the length is very long, and due to its longer length it is it's a overhung boom which is supported by stay ropes. So, here you can see there are multiple stay ropes which are used for the stability of this boom. Again, let us say in case of failure, in case there is any failure in this kind of boom, so this boom is filled with nitrogen gas. So, when it is filled with nitrogen gas to certain pressure, so it maintains, it gives certain stiffness to this boom, so that it does not buckle while it is operating at such a longer length. Now, in case of any leakage, we will be able to see that there is a drop in the pressure of the gas that is filled inside this tubular columns. So, that is all about the long length truss boom. Now, coming to the power transmission. So, as we understood that there are few mechanisms that are happening. So, one is by the hoisting of bucket, that happens by hoist rope. Then there is dragging of bucket, which happens by drag rope. Then there is swinging mechanism, then there is walking mechanism. Then there is also boom hoist, boom hoisting. Okay. So, these are the operations that happens in a dragline. Now, for hoisting of a bucket, so there is a hoist motor, which is like there is a rope, so which has to be coiled over a drum. So, first there is a hoist drum which takes power from the hoist reducer, which is connected to a hoist motor. Now, this hoist motor takes power from the hoist generator. Now, this hoist generator is in line with the AC synchronous motor, and then there is a also drag generator and swing generator. So, this drag generator would be giving power to the drag motor that is here, which again gives power to the drag drum through the drag reducers. So, the first one, the dragging hoisting of the bucket and dragging of the bucket, these two operation happens using these two motors. So, about this part in details Professor Rautray will also be discussing about the deck layout, and he will be explaining how the power transmission happens from the different components, electrical components that are housed on this deck. I am only talking about the mechanism part. Now, for walking from we completed hoist generator, drag generator, and then there is a swing generator. This swing generator gives power to these two swing motors, and through swing reducers it helps in swinging, complete swinging of the superstructure, or this deck completely would be swinging due to these swing motors. Now, here is the operator's cabin who can look at the operation that is happening on the field and can operate the drag rope that passes through these fair leads. As I was discussing, these are the two slots, the guided paths through which the drag ropes is stabilized or handled. Then comes the walking motor or the walking mechanism. So, this walking motor also takes the power from this AC synchronous motor and the generator that is housed at the back of the deck, and it helps in walking of the complete drag line. So, in between there is a control pin which helps in swinging of the superstructure that is housed over this. So, for boom hoisting as well, there are boom hoist drums which helps in lifting and dropping of the boom dragline boom. Now, this picture also shows the deck layout of how it originally would be looking like. So, there is a hoist drum here, and to both sides there are hoist motors. At the middle there is a drag drum, and on the both sides there are drag motors, there are walking motors here, as you can see. There are again swing motors here which helps in swinging of the superstructure. There is fair lead, there is operator's cabin, there is a power control center, there is MG set, 2 MG sets which gives power to the complete deck. Mostly the drag lines that we see in India are electrical drag lines. They are, the power comes from electricity, it does not come from diesel. So, now coming to the walking mechanism that is used in a drag line. So, they can be of two types, they can be eccentric type or they can be hydraulic ram type. Now, when we talk about eccentric type, this is how it looks like, and when we talk about a hydraulic ram type, so it would look somewhat like this, where is a hydraulic piston cylinder arrangement which helps in walking of the drag line. So, now let me explain you in details of how a eccentric type drag line moves. So, as you can see here in this picture, the drag line is at its first step. Okay, so, there is this tub or shoe that you can see here, and there is a eccentric mass here. So, there is a huge mass here, and at certain offset there is an eccentric shaft here. So, which we call it as the walking shaft. Now, this walking shaft gets power from the walking motor. Well, if you can see this point A here, so it would rotate in clockwise direction. So, now you can see below this shaft the distance is this much, and above this shaft the distance to the circumference is more. Now, when the walking shaft would rotate, it would rotate this point A to this horizontal position A. So, there is a vertical shift of the shoe by this much amount, where it would shift the point B to touch the surface of the ground. Now, as you can see, below this walking shaft the distance has increased. Okay, so, you can just imagine as you are walking with your foot. So, now your foot is at rest. Now, you have lifted your toes to certain angle. So, this is at that level. Now, your point B is at the bottom. So, this is a vertical shift of A that has happened, that has pushed this tub to touch the ground surface. Now, in the third case, when it again rotates, you can see the distance has increased below this walking shaft and it is at its maximum level. So, at this level what happens? It tries to uplift the complete machine. So, it is like you are putting your toes down and your heels are up. So, when your heels are up, so you can see that when you put your toes down and you lift your heels, your height would increase. So, your body would move front. So, the same thing happens for the walking mechanism here when your point A moves from this location, that is from its first location to the third location, like it is first in the vertical first quadrant or in vertical plus position, then it was in horizontal plus position, now it is in horizontal minus position, where due to this eccentricity there is a huge mass which would lift the body of the drag line to the front. Now, this point B is pushed back while it moves or it lifts up the body of the drag line. Now, again the point B A would rotate and come to horizontal minus position. So, again the distance decreases and now the point B has shifted back. So, now it is something like heel is lifted and then again you put down your feet. So, again from this point the point A from its horizontal minus position, it would move to vertical plus position, which would lift the tub again to its initial position, and this way the walking of the drag line continues. So, this is a typical mechanism that we see in drag line, which we may not be able to see in any other machine. Now, about the undercarriage unit, about the ball race and central post, we have already discussed in the other machines like bucket wheel excavator and shovel in details. So, this is something similar to that. So, I am not going to discuss it again. So, these are the reference to this topic that you can follow: the SME mining handbook, the Ratan Raj Tatia book of surface and underground excavation, and latest development of heavy earth moving machineries by Amitosh De. Thank you.